Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. We do encourage engagement in the chat, but please be mindful of the commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. Our speaker today is Jim Bennett, who's a regional cloud advocate. I'll now turn it over to Jim.
Awesome. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening. Welcome wherever you are in the world. And I've got another cool wearable to show off because, on Wednesdays, we wear tech. So let me just fire this up and then I'll launch my camera and show you what we've got. Give it just a second to run. Come on, hurry up. I should have started this a few seconds ago, shouldn't I? But in a second, this will launch. How many stars on my MX chip workshop? How many open issues on my happy, sad, angry workshop repo? Cool. So if you saw that happen, you saw I was asking questions about various GitHub repos, and the answers were streaming across this lovely bracer I have attached to my arm. Let's take that for a second. So this is my GitHub status bracer. So if I ever need to know the status of any of my GitHub repos, I can just ask and the answer will appear on my arm, scrolling across this lovely panel. So Matt3 says, okay, that's neat. Thank you very much. Yeah, it is pretty cool. It is pretty cool. Not the most comfortable piece of hardware, I must admit, that I've worn in a while. This panel is definitely a bit too large for my arm. I keep scratching myself on the corner. So maybe a few more modifications to make. But essentially, I've got an LED panel. It's connected to, well, really, this is a archer's wrist rest. So, when you're playing with wearables, sometimes the right piece of equipment to use is whatever works. Well, most of the time, it's whatever works. So this is just a relatively inexpensive archery wrist guard, normally worn the other way around to protect your wrist against the bow. And I'm mounted to it. I've got an LED strip, and this displays the status of my various GitHub repos. And it's all down to me asking the right questions, and this will then give me the answers that I need. And this is what today is all about, showing you how I built this. We're going to dive a little bit into the hardware, not too much because I talked about this on earlier streams. Then we're going to dive into the software and the AI services in the cloud that allow me to make all this happen, and then give you some links that you can then go off and just play with something similar yourself. So that's the plan for today. And Ariadne says hello from Germany. My screen's very small, so it took me a second to spot the German flag there. Hello, welcome. Glad you could join us today. Cool. So I'm going to take this off, just because it works great with a long sleeve t-shirt when I built it. So I was wearing a long sleeve t-shirt when I built it, so it wasn't that scratchy. But now wearing short sleeves is a little bit scratchy, so I need to fix things. But this is the hardware that I've been using for this whole GitHub status tool. Now, if you joined us for the past couple of sessions, Michael asked, can you put the links to your GitHub repos into chat? You know what? Yeah, let's do that. Let's do that now, actually. Let's put links for the GitHub repos into... that's a good idea. Let me grab those quickly for you now. Where is it? I need to actually find the repo. Let me just grab the repo for you. It's going to drop it in the end, but I will add the repo now. So these repos, they just have the code and they have links to the videos from the last 2 week sessions, today's session. I'll be adding up for next week's session as well. So you can kind of follow along with the videos. We talk about the hardware. I haven't written up the hardware side of things yet. That will be coming later. So yeah, that's the link there. And Michael says also hello from Western Canada. Hello from Western Canada. I guess very close to me. I'm on the west coast of the US, up in Washington. So yeah, I'm kind of close to you, but just south, I guess. I'm about 2 hours south of the border. Of course, as you can probably gather by the fact there's conversation going on in the chat, this is definitely an open session. You can ask questions all the way through. Yeah, happy to kind of change direction, talk about some of the stuff we're doing as we go along. So please comments in the chat, ask your questions, and I'll do my best to make sure I answer everything that comes up. Cool. So very quick look at the hardware. As I say, in the earlier sessions, the hardware, yeah, we cover the hardware in more detail. But essentially, everything's built around a Raspberry Pi Zero. Well, 02, in fact. If you've not come across Raspberry Pis before, Raspberry Pi Foundation is a fantastic manufacturer of hardware. The original Raspberry Pi was designed to be like a $30 computer for kids to use to learn to code. Plug it into your TV, plug in a keyboard and mouse, and just code away. And you can just, yeah, kids could learn to code Python, Scratch, things like that. Since then, they've expanded. You know, they've hoped to make, you know, a few tens of thousands of boards. They now sell millions every week or millions every month. Limitations at the moment on supply chain, but they make a lot of great hardware. And this, the Raspberry Pi 02W, it's essentially Raspberry Pi 3, if you know the Raspberry Pi. It's a pretty powerful little board, runs a full version of Linux, can plug in, you know, HDMI port, mini HDMI port in there, can plug in a monitor, keyboard, mouse, run full desktop Linux. Nice little powerful beastie. Connects over Wi-Fi, and then I can use this to drive a whole load of hardware. And this is connected to this LED strip, this LED panel here, which has got 256 fully programmable LEDs, also connected to power as well, to power these things. And then from the Pi, I can control each LED so I can kind of scroll text across it, things like that. That's about as far as we'll dive into the hardware. So the last few sessions, we actually looked at this a lot more. Last week, we looked a lot about the LEDs. Week before, we kind of dive more into the Raspberry Pi. But let's actually focus on building this GitHub status bracer. Let's actually focus on building out the technology that I can use to allow me to ask for information about my GitHub repos with my voice and then get that displayed on the panel. So let's build it. So let's start by creating myself a folder and open up in vscode. Now, if you didn't come to my last few sessions, Visual Studio Code has this great remote SSH extension. And so I'm currently connected to my Pi. I'm on my Mac, Windows. I work for Microsoft. I'm not using Windows. I use a Mac, you know, a little bit of a rebel, but you know, any developer, any platform. And I'm connecting to my Pi using Visual Studio Code. So you'll see I'm opening a folder /home/Pi. This is a folder on my Pi. I'm opening it as a remote connection. So it's nice little down here. There's bright green SSH 0 local. That is me connected over SSH to my Pi. So top tip, if you're doing any Pi development, you can do it on Visual Studio Code. There you go. And so here I am. This terminal is the terminal for my Pi. If I open up any files here in the Explorer, they're on my Pi. The folder is on my Pi. And when I run code, it runs on my Pi. When I debug it, it debugs on my Pi, which is a really, really cool feature of Visual Studio Code that I can do this. So I'm just going to create a new .NET application using C# for this, just because I can. And Python's the usual language for building IoT projects on Raspberry Pis, but there's been a lot of really great .NET IoT libraries coming out recently. So I can do all my IoT stuff in .NET. So I thought it'd be fun for this series to do everything in .NET. And then what I'm going to do, I'm just going to add some .NET packages. IoT device bindings is a library to control Internet of Things devices. The JimBobBennett.neopixel ticker tape is a library for scrolling text across it. And then Microsoft Cognitive Services Speech is a library for allowing me to interact with speech services in the cloud. So all the AI work that's done on here, it uses AI to interpret what I say into text and then to break that text down into an understanding to find out what I'm asking. All that is run in the cloud. So my my Pi will connect over Wi-Fi or a tether to a mobile phone if I'm out and about, connects to the cloud, and then uses AI services in the cloud to run everything. So the speech to text stuff, worked through this in the last couple of episodes. So not going to dive into that. Same with the ticker tape library. Not going to dive into that today. What I'm going to do is I'm just going to paste some code in. So I've just pasted some code in that connects to my speech service and does speech to text and then scrolls it across the panel. And yeah, just going to run this to show it to you. So again, not diving into this in any detail. Check out the previous videos where I go into this in more detail. But let's just get it working as kind of our base level point, and then we take it from there. So while it's building, quick run through the code for those interested. Got my key and region for my speech service. Set up my NeoPixels, which is my LED strip. Set up connection to my strip. Got some code here to actually. I don't even need that code. That's old code. I don't want that code. Got my speech recognizer. Listens for English to my microphone, and then when it recognizes speech, it scrolls text. So I grab my very nice Bluetooth headset. Hello, world. As I speak, it appears on the LED panel. Cool. So yeah, not going to go into that in any depth. That was literally what we did in the first episode in the series, but that's just going to get me my base point ready to build out. Ariadne says, I was raised on a Mac, stayed in that universe. But having said that, VS Code is one of the greatest pieces of software. Thank you, Microsoft. Yep, totally agree. I love VS Code. I pretty much live in VS Code for everything I do. But I love the fact it runs everywhere. So it runs on my Mac, runs the same as it would do on, if I was running it on Windows. It runs on a Raspberry Pi. So if you have a Raspberry Pi 4 or Raspberry Pi 400, you can literally sudo apt install code that will install VS Code, plug in your monitor, keyboard, and mouse, or no keyboard if you're using 400, and you've got VS Code running on the Raspberry Pi, which I think is absolutely fantastic because it's just Linux. Raspberry Pi runs Linux. I can run VS Code on there, and it's great. Another thing I love about it is the way that it can connect to things. I can like SSH to my Pi, or I can SSH into a container. I'm doing a session 4 p.m. today, my time. So that's, what are we? We're 9 o'clock in the morning now. So 7 hours time, I'm doing a session on how to use containers. So I can literally, you can, in VS Code, you define what you want in your container. That goes into source code control, and you just spin up your container and connect, and you've got a kind of perfectly set up dev environment for you. So yeah, it's absolutely fantastic. And Ariadne says, agreed. Most important to me, it runs on the web. Yes, I love this. The fact I can go onto a repo like this and I can tap full stop key and bang, Visual Studio Code running on the web for my repo, and I can make changes to my repo. So it's absolutely fantastic. You can run it on the web. Also, we do a thing called code spaces where we spin up a virtual machine for you that you connect to and run your code in that. And it's just, yeah. VS Code is incredible. Absolutely incredible. So yes, loving all this VS Code link. Could you post a link to this talk too? The one I'm doing tonight on using containers. Yes, certainly. We will get a link to that put in the chat. Irina can sort that out. Put a link to tonight's session in the chat for you. It'll be recorded, so I guess obviously if as you say you're in Germany, so it might be the middle of the night. Code spaces, cool. Yeah, I use code spaces a lot. I love it. But yeah, the session will probably be in the middle of the night for you. So obviously join us live if you want. If not, it'll be recorded. So yeah, Irina can put a link in the chat for you. Cool. So let's dive into what we're actually trying to do today, which is build this GitHub status bracer. And so what I need to do is I need to go from me saying something, saying, how many stars on my repo or how many open issues on my repo, and go from that into something the computer can understand as a set of instructions on what to do. Now, there's multiple ways I could do this. I could literally just take the text that comes out the speech to text engine and search for specific features. And so, I could say you always have to use a certain specific expression. So I could say you always have to say how many open issues in the repo, whatever, or how many stars for the repo, whatever. So I could do that. I could do that to kind of build this, which would be easier. But we as humans, we don't say the same thing the same way every time. We don't say how many stars on the repo, whatever. We might go, my repo's got how many stars? How many stars on the whatever repo? We might say it different ways. So what would be better would be to bring some kind of conversational understanding to what I'm doing. And that's kind of what I've been using to build this out, is using language understanding so that I can ask a question multiple ways and then have that interpreted through language understanding. It's pretty cool. Oh, Fuel Snable says, are you using omnisharp in VS Code? Whenever I use omnisharp, my machine chokes. Yes and no. Great question. Yes and no. So I do have omnisharp installed. It's the C# extension in VS Code. I do have it installed, but it doesn't work very well on the ARM v7 hardware that the Raspberry Pi 2.0 uses. It's actually, if I reopen this project, it'll tell me that it can't do any remote debugging, things like that. So it's limited to what you get with a Raspberry Pi. Running locally, you get all the things. If I run it on my Mac, I get all the things. On the Raspberry Pi, it's kind of limited in what it does. So I don't get full auto completion. So if I try and do this, it just guesses as to things that it might be. It doesn't actually analyze the object and understand the object. So yeah, there's a lot of limitations when using the Raspberry Pi, unfortunately. It does have the syntax highlighting and things like that, but yeah, it doesn't actually do a lot of the other stuff on the Pi. Cool. So Ariadne, we just posted the links to the event for this evening if you want to actually watch that, which is cool. Yeah. Autocomplete is what I want. The rest is not so important. Yeah, unfortunately, you don't get that on the Raspberry Pi. You don't get that on the Raspberry Pi at all. So for that, what I've been doing when I need autocomplete is I develop on my Mac and do everything there just to get the autocomplete working, and then copy and paste the code over back onto my Pi. It's not perfect, but it's a way to do it. If I was using a Pi 4, I think it works better on the Pi 4. It's just the Pi 02, not so powerful. Cool. So scrolling back to some of the comments, Jealous7 says some keywords in the question, right? Yes and no. I mean, what I'm actually doing with this is building a language model where it learns to recognize certain keywords. So I don't write any keyword spotting myself. I'm actually going to be using a language model, which we'll dive into in just a second. Fusenable says, I don't get autocomplete on my desktop and work laptop because of 99% CPU. Wow. That's weird. I don't get that with OmniSharp on my Mac. Maybe that's time to buy a brand new computer. Maybe, go to your boss and say 99% CPU. I can't do it. I need a top of the range Mac Studio. I tried that once. It didn't work, but maybe now's the time to go to the boss. Yeah, too expensive. Yes, unfortunately, getting beasts computers to power these things can just be prohibitively expensive. Yeah, I feel you. Cool. So let's actually look at language. And so we actually have a tool from Microsoft. Graphics cards are crazy these days. Yes, graphics cards are just horrendous. Absolutely horrendous. Who'd have thought that in the time of pandemic, graphics cards would just get that expensive? Supply chain issues and Bitcoin miners, Cool. So let's actually talk a little about the AI side of it, the whole language side of things. Now, building language models is hard. Building language models is very, very hard, which is why I don't do it. What I do instead is I use language models that other people have built. And I can use those I can train those on the language I want. So one thing Microsoft does really well, we have this whole suite of AI services called cognitive services. This includes things like the speech to text service that when I speak, I get the text out. And we have a language service for this. So I'm just going to drop a link in the chat to our language studio. GPU prices are coming down to MSRP. That's good. Good to know they're coming down because they have been insane. I blame Web3. Yeah, probably somebody's using them to mine Ethereum to buy pictures of monkeys that then get stolen because, yeah, decentralization has no security. No facts or grounds for this. I just do. Yeah. 2022, facts are needed. Yeah. Who needs facts? Just blame Web3. It probably is something to do with Web3 anyway, Oh, I have so many opinions on Web3 and all that, but I won't go into them now. Anyway, what I will go into, yes, it's good chat. I'm enjoying this. Let's dive into this whole language thing. So in the last session of this series, I set up a language model for doing sentiment analysis. So if you join me for that session, Ariadne says, Web3, don't get me started. Yeah, I'm with you on that. Yeah. So the last session of this series, I built a Be Kind-O-Matic. So it's a hoodie that lit up around the hood, red if you said a bad thing, green if you said a good thing. And that was using our language understanding models. So we've got a whole lot of AI models in the cloud, part of our cognitive services that can take language and understand it. And I can actually customize these models to learn what I want it to learn, and then you use that to get information back about what people say. So it's all down to something called natural language understanding. And we have a whole lot of natural language understanding models that you can use in your applications. So extracting personal identifiable information, spotting if somebody's put a passport number or date of birth or an address in something, putting out key phrases, linked entities. So this is to do with that. Named entities, looking for pizza, and then you can find it in their health information or custom named entity recognition. So kind of lots of options you can do to kind of find out information from text. And we've got stuff for classifying text and mining opinions and answering questions and all that. But I've been using custom named entity recognition. And custom named entity recognition allows you to define the entities that you want your model to detect from a sentence, and then the intents that folks have with those entities. It sounds very confusing, but essentially what it means is you define. Let's go back to the project. Essentially what it means is you define the kind of intent behind a sentence. So you can say this sentence might be, I want to order a pizza. This sentence might be, I want to order a salad. This sentence might be, I want to book travel. You can define the intent behind a sentence. Like sentiment analysis, says Ariadne. Similar, kind of, yeah. And the sentiment analysis is kind of trained on whether something's a good or a bad thing. This is very specific to certain sentences. So if you were to say, I would like a 12-inch pizza to go, your intent is buying pizza. If you say, can you deliver me a curry? Your intent is ordering a curry. If you say, yeah, I could do with a coffee, your intent is buying coffee. So you kind of look for kind of intents in what's there. And in fact, actually, it's if you say, I'd like to order a pizza, I'd like to order a coffee, can I buy a coffee? The intent that really is to purchase something. And so you kind of understand that the model understands that your intent is to buy something. And then you have what's called entities, which is what the intent applies to. So if I said, I'd like to order a 12-inch pepperoni pizza, the intent is buy something, the entity is a pizza, 12-inch pepperoni pizza. If I said I want to book a flight to New York, the intent is to book travel. The entities are flight and New York. Or maybe I can have an intent of book a flight with the entity as New York. And then if I'd said I want to book a train to New York, the intent would be book a train ticket, entity would be New York. So kind of define the intents and entities that you want to have inside your code. So I've got two intents defined. One's called get issues and one's called get stars. And so when I want to say how many stars does my repo have, that is a get stars intent. When I say how many open issues, that's a get issues intent. And then I define my entity. And I've only got one entity here, which is my repository. And so I've defined my entity as my repo. So this is kind of defining my schema. I'm not really doing much behind it. I'm just saying there's two intents of what people might ask for. And when they do these intents, the entity that comes out is a repository. So that kind of sets the framework for my model. I then give it what's called utterances. And utterances are sentences. And in the sentence, I say, this is the intent of the sentence, and this is the entity that the intent applies to. And I do this for a whole lot of sentences, and then I say, go off and learn. It sounds a bit crazy, but that's kind of what it is. So I will define a sentence here. What's the issue count for the happy, sad, angry workshop repo? I've defined the sentence. I've said this sentence is a get issues intent. And in this sentence, this block here is the name of the repository. This is the entity that my intent applies to. And so on and so on. The Planty repo has how many open issues? This is get issues intent. This is the entity that it applies to. And so on and so on and so on. I just give it different ways of saying the same thing. So this is kind of part of what builds up this model is I give it a lot of training data. There's different ways of asking the same question. And then I tell it, when you get asked this, this is kind of how you identify the repository. It's pretty cool. So if I want to add a new one, I could say get issues. My Wednesdays where tech repo has what open issue count. I could do that as my sentence. Add this, and then I just literally draw on here my entity. So it's kind of this nice little tool where I just write the different sentences. So the entity is not so much an object, but more like a function awaiting more data. I mean, the entity kind of is an object because the entity is, yes, I guess it kind of is an object. It's part of the sentence. Because I could stuff anything in the repo as data. Yes. Oh yeah. I mean, it's understand. I mean, the contents of this repo could be absolutely anything. It's just the code is trying to understand what that means. And obviously, when I run this model, what I would get out is I would pass in a sentence. I would say, here is my sentence. My Wednesdays where tech repo has what open issue count. I pass my sentence, and what I get back is I get back a intent. So what? I get back a probability of all the intents with the top intent. And it says, I think this is the intent, get issues. And then the data I get back is, then I get back the list of the repos, which could be more than one. And I just get back this list as data. So really it's not, I don't know, there's not really a function or an object really. It's data that comes out of it. I can stuff anything through repos data that's more of a function. It's more a case of the model as a function. The model is the function that kind of works out how to build itself up. And the results of the function are the entity and the repo. And that could be one or more repos. So we kind of put data in and then we get back 2 data points. And the internals of that function is the magic of the AI model. I hope that makes sense. It is a bit magic behind the scenes. But it's literally, this is the input to my model, and the output is get issues, Wednesdays we wear tech. So the model is more the function. So I do this, I build up my utterances for issues and stars, and I just put this in there. And then I don't have to do, apart from defining where the entities are, that's all I have to do on my model. And then once I've got that, I'll discard the changes for now. I can then go off and train the model. And this then will go off and it will build my model, look at the data I've got, and then try and build this model for me. Now, the more utterances I give it, the better the model. I've currently got 20, and that's enough for it to work. But the more data I give, the better the model. Now, when I'm actually building these models, I can do multi-language as well. So I think it's when I set my project. If I were to create a new project, for example, I could choose the primary language of my project and enable multiple languages. So where I am, for example, I live in the US. You phone up whoever, and the very first thing on the menu is press 1 for English, and then it says in Spanish, for Spanish, press 2. And so if I'm doing any kind of bot, I may want to work with both English and Spanish. And so here I can actually have multiple languages. So if you want to have multiple languages, you can, and then it's just the more utterances you give it, the more input data, the better it gets at learning. And then you kind of want to split the data between testing data, training data, and all that. But a lot of that happens automatically. For getting started, for folks like me, it's just bang in a load of utterances and click train. Now I'm using utterances I've already created because watching me type in 20 of those is very, very boring. And I've already pre-trained my model because training it takes a long time to run. And you don't want to sit there and watch me spend 10 minutes doing it. But I can train a model, and then when it trains it, it can either automatically split the data or manually split into what's called training data and testing data. So I've got 20 utterances, and when I train it, it uses 16 utterances for training and then 4 utterances for testing to actually validate how good the model is. And then once my model's trained, I get my model details here. This is my model, and only took 3 minutes, 4 seconds this one to train, but it gives me the precision, the recall, and the F1 score. Not entirely sure what an F1 score is. I think it's just a measure of how good it is. But this is saying basically if it reruns all the data that it's got already for the model, it gets 100% success rate, and if it retries things it's done, 100% success rate. So so far it's not a bad model. Not so good at getting the repos. We're only on like 25% precision on the actual repos. So the idea behind this data is it shows that if I give it an utterance, it's pretty much guaranteed to know whether that's get issues or get stars. But it may not get the repo right. And a lot of that is because repos names can be made up of multiple words. So when I have like my happy, sad, angry workshop, it might actually detect multiple repos: happy, sad, angry, workshop as 4 separate repos. So it's not so good at identifying the repos, but it's really good at getting the intents. But we can kind of do a bit of work in our code to kind of work around this. But it's kind of good to see the results of the model here, see how good the model is. So Michael asked, if I already have an Azure environment and have for a while, is there a way to get the benefits of a trial to play with this without cost? Great question. You can sign up for an Azure free account using a different email address. It's probably the best thing to do if you want to play with this. So I'm going to just grab I'll just grab a link to that, drop that in the chat. If you sign up for an Azure free account, use a different email address. You have to use a credit card when you sign up because we want to verify you're a human, not a bot. We don't bill your credit card. Do not. You get $200 of free credit for the first 30 days and then a load of free stuff for 12 months. So that's kind of a good way to get going because if you were here last week, when I set up my language model, I used the free tier. When I'm using the language studio, I can't use the free tier for that. I have to sign up for a paid standard tier. And so, yeah, it's relatively inexpensive. We are $1 US per 1,000 text records. So 1,000 analysis is like it's $1. But if you want to do it without cost, then yeah, just sign up for the Azure free account with a different email address. Obviously, if you can't use the same credit card for different Azure free accounts. If you signed up for one using one credit card, you can't use that with another free trial because we don't want bots being set up. But yeah, that's a way you can get going and have a play with this. I mean, all the stuff I'm doing doesn't cost anything. We're still within kind of free limits as far as I know. And if it does cost, it's only going to be a few dollars. So great to play with it using the free account. So yes, I've got my model. Once I've got my model, I need to actually publish this model somewhere. So I need to actually host this somewhere. This is kind of why you have to go for a model with pricing, because we host this model in the cloud and run it for you. So you've built it, you've trained it, then we host it in the cloud. So I then click the deploy button and I choose my model and that just deploys it and that goes up in the cloud. Once I've got a model, I get a URL that I can then use to actually test it out. And then I can test it. And there's actually testing here inside the UI that I can use to test my model. So I could say, right, GitHub status brace deployment. What's the star count for my happy, sad workshop repo? Run the test. Top intent, get stars, 100% confidence. And then happy, sad, angry workshop repo. The original text, what star count? So it's intent, bang, got it right. Repo, it's put the word repo in the name there. So it's not quite perfect, but it's kind of close enough. I can write code to understand this. So my intent is get stars. I could go, what's the MX chip workshop repo issue count? Nah. Get issues 100%, MX chip workshop repo 100%. So it's got that one right. So it's pretty good. I can just have a quick test of it here and I can see the results. And then once I've got these results, if I can then use this to go back, retrain my model, add more utterances and so on and so on and so on and so on. And that's my language model. So I can now use this in my code. So let's do that now. Go back to my code here. I'm just going to add the Azure AI language conversations package. The minus pre-release, because this is a pre-release version of the package. And this gives me code to then call into my model. Well, let's bring that in. Going to add some using directives into here. There we go. And then I'm just going to define a few endpoints. So I need to define the conversation endpoint, which is the name of my language service, which if I go back here, is this, where is the, yeah, it's a little bit annoying because it's a preview service. If I pick my deployment, get my prediction URL, it's just that bit I need. Not the whole thing, just the jimswearables.cognitiveservices.azure.com. So when I create this, I have to give it a unique name. This is the endpoint I need to tell it in the SDK. I need to give it my key, my magic key, which is here in my project settings, hidden away down here. This is my keys. This is my authentication. So it's key-based authentication. So that's a bit of code there to kind of define some keys. And then let's actually create my client. I'll do that down here in my main method. This is my client. So I define my key credentials and create my client. My client can then be used for processing my text. I'm going to add another method on here called get response for speech. This will take my client, take some speech, grab my project, and then when it points to a particular project. So inside my Language Studio account, my endpoint and key, I can have multiple projects and multiple deployments. So in here, I have to say what project and what deployment. This maps to this project here and this deployment. I have multiple deployments per project, multiple projects per account. So I have to tell it which one I'm using. And then I can analyze the conversation, analyze some speech, and get back a response that comes back. Now, once I've got this response, I need to then process this to pull out some data. And then in my response, it has a value. That value has a prediction. It's going to have to dive into the response object. Going back to Fuel Sabel's questions earlier about IntelliSense, yeah, I did this part. I wrote on my Mac to get the full IntelliSense because OmniSharp doesn't have that on the ARM v7 hardware. So I wrote this part on my Mac to make the IntelliSense work. But yeah, once I've got my prediction, I then get the top intent. So like with a lot of AI things, it's not a binary yes, no type answer. It is this at this percentage, this at this percentage. So I get the top intent, the one that it thinks has got the highest percentage chance. And then I get back a list of my entities. And this entity can be, I can get back multiple entities. So it might detect a repo name as, say, 3 repos rather than just 1. So what I do is I'm going to add another little bit of code here. It just joins the entities ordered by the offset to build up the repo name. So if I ask about my happy, sad, angry workshop, I might get back 4 entities, 4 repos: happy, sad, angry, workshop. And so I go through these, I order them by the offset and assemble them. So the offset is where in the text it's been detected. So it tells me where in the text the repo actually is. So order them, and if there's a repo on the end, because we saw back in one of the tests, it disappeared now, but it put repo on the end. I just remove that off the end to try and make it look like my repo. And then once I've got that, I can then take my entities and get back the name of my repository. Now, what I want to do is I want to understand the intent. Now, the intent when it comes back from here is a string. It's just the string text, the intent, which will be get issues, get stars. I'm just defining a little enum here that I can then use in my code, and then a bit of code here to convert from the string name to an enum. Just makes my code a bit clearer. And then down here, I'll just say get the intent. So that gives me my repo name and my intent in kind of a useful thing. And then I'm just going to dump this out to the console for now. This return a bit of text that says the repo and the intent. Kind of do a first pass of just what is the repo value and what is the intent that comes back from the language model. And then what I'm going to do is in my speech code here, I'm just going to change this. So when I say something, I'll get response, send it to the model, and then just writes the response out to the ticker tape. So let's run this. Get this going. We'll see the output that comes out when I actually ask the questions. So, don my fancy Bluetooth headset. So if you're doing any kind of voice control with a Raspberry Pi, you need some kind of way to talk to it. So I've got this. I find these little Bluetooth headsets are great. This one's actually got a little dongle. How many stars on my MX chip workshop? How many stars on my MX chip workshop? What's the open issue count on the on Wednesdays we wear tech repo? So as you can see, it's processed that. If I look at the first one, how many stars on my MX chip workshop? Repo detected, MX chip workshop, intent, stars. So it's pulled that out. What's the open issue count on the Wednesdays we wear tech repo? It's only got on Wednesdays of the repo, top intent, issues. So it's got the issue right. It's got the intent right with the issues, not so great on the repo name. But it's not bad. It's not bad. Of course, I'm only training it with 10 utterances of each. And so we can get this better and better and better. Now, what I want to do now is actually tie this back to a repo and actually show the data. Rather than just recognize I've said this, I want to show the data. So I'm going to use a thing called OctoKit. OctoKit is a whole lot of libraries for interacting with the GitHub API. GitHub has got a fantastic API for doing stuff, and they've got wrappers like octokit.net to interact with GitHub over for a .NET API. And I can use this to query my repos to get everything. And so I just add OctoKit. Not really going to dive into too much on how OctoKit works. Add the OctoKit using, and then let's define a connection to OctoKit. Now, yes, you can see my API keys, my language model, my speech service, because there's not much, you can't do much damage with that. I'm hiding my GitHub API key. When I connect, I need an API key to otherwise I get rate limited to 1 request a minute. So I'm hiding my GitHub API key in environment variable because I don't want you to see that one. And then I need to start building up some repo names. So what I'm going to do is I'm just going to add a bit of code in here. Not going to dive too much into this code, but this code essentially loads all the repos for me and then splits it into something that looks like text. Because if I'm building repos, I will build them in camel case. I will use hyphens between words, and I want it in a way that could be recognized, that's kind of matches how I would say something. It means it's easier for me to kind of match a repo name that I say to the actual repo name itself. So I'm just going to split those up into use sensible words and add those to a dictionary. So I've got a dictionary of what I think is, well, what's the actual name of the repo and a more humanized form of the word. And then I'm just going to load all those in there. In fact, let's just run this so you can see what the output is. .NET run of loading that. Now, I've got, once I load my repo names, I need to actually tie back from what I say to the repo. So what I say may not exactly match the repo name, just because that's just, the words that are understood may not pick up the same way. It may not understand if I say Xamarin, I've got a Xamarin repo, it may spell Xamarin a different way, things like that. So what I need to do is find the closest repo name to what I've said. And I'm going to do that using a thing called Levenshtein distance. So in a second, when this runs, shows the repo, I'll install this. But the idea is that Levenshtein distance is a measure of, here we go. So here's my repos. So like tic-tac-toe becomes tic-tac-toe. Tone analyzer becomes tone analyzer. Virtual IoT lab becomes virtual IoT lab. So kind of humanizing it to make it a little bit easier for me to kind of tie up between the repo name and what comes out of the language model. So I'm going to install a thing. Ooh. Okay. So I'm going to use a thing called Levenshtein distance. And Levenshtein distance measures how many changes do you have to make to one thing of text to make it look like the other thing of text. So if I say, "You're a mean one, Mr. Grinch," as my text, and it puts you're with an apostrophe in there, "a mean one, Mr. Grinch," I would need to make one textual change between "you're a mean one, Mr. Grinch" with apostrophe and this without to say it's the same one. So that would have a Levenshtein distance of 1. Whereas if I compare it to Xamform's MBX template, I'll have to change 1, 2, 3, 4, 5, 6, 7, so many different letters that has a high Levenshtein distance. And I can use this to kind of find the best name match for my repo. Not going to dive into that in too much detail, but Levenshtein distance is kind of a good way to measure this. It's got a bit of code here. Give it a repo name that it gets from my model, and then just goes through all the repos and finds what's got the lowest Levenshtein distance and then returns that one, spits that one out. And then what I can do is where is it? Where's my get repo name? Here we go. So when I actually get my repo name, joins the entities, makes it all up, and then looks for the best match. So it gets kind of the best repo from that. So if I now run this, what we should get is a much clearer idea of which repo we're interested in. Pairwise sequence alignment. Cesare Adonai. I don't know. I don't know. I know the name of Levenshtein distance. I know that it does stuff, but I couldn't tell you how it works. So Yeah. I don't have a degree in computer science, so I will believe you on this. Yeah. I don't know. You're probably way smart. If you mentioned doing computer science, probably way smarter at this kind of stuff than I am. I just Google how to do things. How many stars on my You're a Mean One, Mr. Grinch library? How many stars on my You're a Mean One, Mr. Grinch repo? I hope if I say it correctly, doesn't it? So yeah, picks up weird stuff. I said library, and so it picked up that one from the library. But when I say it right, how many stars on my You're a Mean One, Mr. Grinch repo? It detects You're a Mean One, Mr. Grinch is the closest one. And then yeah, say random things like hopefully correctly doesn't. Things IoT ugly sweater is the close one. Now, obviously, the first thing I'm doing here is just literally getting the closest one based off the Levenshtein distance. The smart thing to do would be to actually define a minimum. So if it doesn't detect a good enough match, then it just doesn't give you any answers. But I haven't done anything that flash. I'm just trying to get the quickest one. Aaron says, me neither. Ex-PhD student of ancient history. Wow. That's very cool. That's very cool. Did you ever do any stuff with in terms of ancient history? Did you ever do any stuff with ciphers? Yeah, things like the Caesar cipher. Julius Caesar used to use to encrypt text. Yeah, I'd love to do some kind of shows digging in some of the really old-fashioned cryptography that was done, thousands of years ago. So, love to stuff that. Thank you for your patience. Of course. This is a conversation. I'm kind of here to work with all of you on kind of showing this stuff off. So, this is a conversation. We're all kind of learning this together in some ways. So it's all good. Cool. So once I've kind of got my best repo, I can then actually pull out information from the repo using the OctoKit library. Yes. Oh, so yes, you are into, as in, if that's a yes to the question on ciphers. Yeah, cool. Yes, I really want to do some whole stuff, kind of just playing with how to write a Caesar cipher in whatever programming language, Python, and then digging more into some of the ciphers. Yeah, I love the fact that like classic Indian literature, they talk about how ciphers were used for couples to kind of share love notes to each other without their families realizing it. It's kind of, you read the stories about Caesar using it in war, and we all know war is a terrible thing, but when you read some of the stories about how in India they used it to share love notes, it's beautiful, absolutely beautiful. So yeah, I'm gonna definitely want to do a dive into ciphers like that one these days. So oh, you're awesome. No, you're awesome. Yeah, you're beautiful. Was it from Keanu Reeves? You're amazing. You're all amazing. Thank you for joining. Please, yes, yep, cool. All right, make sure you follow me on Twitter. I'm at Jim Bob Bennett, and I'll do an announcement of when I'm got a stream coming up on classic ciphers. It'll be so much fun. Cool. So, right, coming back from that slight distraction dive there, which is very cool. So this is how I'm getting the repo details. OctoKit is great. I can literally request a repository from the user and the repo name, and then just ask for the open issues or Stargazers count, and it just gives me the results. And cool thing, I wrote this function on my Mac rather than on my Raspberry Pi using GitHub Copilot. And I wrote switch intent, and GitHub Copilot filled the whole thing in. It guessed, based off the fact I had intent issues, I wanted the open issues count, and intent stars was Stargazers count. It just worked that out. It was just GitHub Copilot built this entire code for me just for me writing switch intent. It was just insane, absolutely insane. But yeah, so this is what I need to do to get all the details. And then when I build my response here, instead of just spitting out the repo name, the intent, I spit out the repo details, and that is it. And then I can do .NET run. While that's running, Michael says, ancient ciphers are a very deep rabbit hole. Be careful. That was what got me into InfoSec. Yes, very deep rabbit hole. I do have somewhere. Just digging through my book collection at the back here. Where is it? Yeah, great book called Decipher. And this is all just got a load of kind of classic ciphers all throughout history. A load of kind of ancient ciphers and the Atbash cipher and the Firestos disk, and moving all the way through from kind of the classic ones through to modern ciphers. And yes, maybe we should do a series on ciphers and dig down that rabbit hole, because it's an awesome rabbit hole. Yes, we'll do that. Cool. Right. Anyway, let's just test this code. How many stars on my MX Chip Workshop repo? How many open issues on my Happy Sad Angry Workshop repo? My Happy Sad Angry Workshop repo has how many open issues? What's the star count on my Happy Sad Angry Workshop repo? Pretty cool. Pretty cool stuff there. So what it's done is it's gone off to GitHub, or it's taken my language. So my Happy Sad Angry Workshop retail has how many open issues? It thought I said retail rather than repo, but it picked that up. It used that. It ran that through the language model. The intent that came out was issues. The repo that's detected was Happy Sad Angry Workshop. It might have been multiple repos as entities that it had to assemble. It then ran the Levenshtein distance and found Happy Sad Angry Workshop, which tied back to this actual repo name. And then it made the call using OctoKit to get the issues and found 3 open issues. So if I asked for open issues, 3 open issues, star count 9 stars, and then as you saw, that just goes straight to the bracer, and so I can have that on my arm, and at any time I can just ask the question and get it there. Now, all I need to do now to be smarter, because I don't know if you noticed, it came across 0 stars, 0 stars, is I just need to put something in there to say a limit. When I get the repo name, if it doesn't really match, if the Levenshtein distance is too much, ignore it. If I, when I get the intent back or the entities back, it comes with a percentage. If that percentage is too low, then maybe I should ignore it. But that is basically the whole thing working. That is my GitHub status bracer. Before we wrap up, though, Ariadne says, rabbit hole is what makes life fun. Yes. You just digging into these rabbit holes can be so much fun. Just geeking out on some of this technology is brilliant. Michael says, I have that book on my shelf too. It's brilliant as an introduction. Yeah, it is a great book. Such brilliant stuff here. Just the fact it goes from the basics right up to kind of talking about kind of quantum all the way through is just, yeah, really good. So maybe we'll do a series playing with this book. Yes. Curious Dev Cookie. If that's you on, is that you on Twitter? If so, I'm going to follow you, because that'd be, yes, do some we can chat ciphers and rabbit holes. Yeah, 100% agree on rabbit holes. Yeah, functional programming is a rabbit hole. Yes, functional programming is a brilliant rabbit hole. I know I'm coding today in C#, but I'm an F# nerd. I do like a bit of F#. So functional programming, once you get your head into that immutable state and all that, it's just brilliant. Yeah, I do love a bit of functional programming. Deniska says the test was cool there. Yeah, it's just great when you see it working. You kind of bring all these bits together. You just use these AI models in the cloud that are pre-built and they do all the stuff for you to go from what you say to text, then text to understanding, and then you use that understanding for whatever you want to do. Is just brilliant. This is kind of the driving technology behind bots and kind of this whole human-computer communication thing. It's just brilliant. Just watch the fact that I can throw this together in a relatively short space of time. Caveat, I kind of used to use these APIs, but this is my first time actually using the new language studio we've got. And this took me probably a couple of hours to go from I want to do it to actually having it working. So the fact we've got these tools available is just brilliant. I love this kind of stuff. It's cool. Ariane says yes, the series. Okay, fine. We'll organize that. Probably going to be for June, but we'll do some sessions on ciphers. That'd be cool. Scott Wallaching comes to mind. Yes, so he wrote a whole lot of great stuff on functional on F#, which is pretty cool. He did does a great sort of talks on basically railways. So he uses railways to do functional design, which is absolutely brilliant. I wonder if I can find railway-oriented programming. Oh, yes, it won't end up because that's an ad, and I've got an ad blocker on. But yeah, his railway-oriented programming is just brilliant. Well worth a search for that. Go away. Oh, this is the one from. This is his talk from NDC. This is a short version. Full version here. Here we go. I'm not going to sign up. Whatever. But yeah, search for his railway-oriented program. I actually saw this one in London. It was just absolutely brilliant. Highly recommend that. So yeah, don't know why it's not playing. Oh, there we go. There we go. This is only a short version of it, but yeah, it's a long version on Vimeo. Really good as railway-oriented programming. Well worth searching up. Cool, but yeah, so that's everything. This is my GitHub status bracer. So hope you enjoyed today's session. Reach out to me on the internet, all over the internet at Jim Bob Bennett if you've got any questions, and I'll see you back here next week for a reading parrot, a parrot that sits on your shoulder and reads to you.
Thank you, Jim, and thank you, everyone, for joining. If you have any feedback, we would love to hear from you. Please visit that link. The event code for this specific event is 15678. We'd love to hear from you. Until next time, thank you.
Well, thanks, everyone. And please fill in the survey. We'd love to know what you like, what you don't like, so we can make sure we deliver the best content. So fill in the survey and say, I want Jim to talk about ciphers, and then we'll do that session.
Thank you, everyone.
Cool.
Bye.
Bye.